What we see here is an Emerson friction drive. Sold at Sears. This is the 52-inch model. Longer blades and such. Uses a little variable speed knob. The canopy is not a bell canopy, it's a twist lock canopy, almost similar to something you'd see with a ball socket fan, only it does not mount that way. So now, a few of you may know, a few of you may not, but the Emerson friction drive was Emerson's shittiest ceiling fan. It was the shittiest ceiling fan they ever made. The blades are plastic. The motor housing is plastic. Pretty much like, you know, every other Emerson in the late 70s, early 80s. Mainly early 80s, but you get the point. Okay. It is a friction drive motor. What it uses is a 6-pole shaded pole motor, about the size of a box fan motor, which has a rubber drive wheel on the shaft, which then drives a hub in which the blades mount to. So, this is an early one, because the hub, or not the hub, the drive wheel is rubber. Later ones were metal, because if the fan is not used for a while, the rubber drive wheel will deform. And when that happens, you have a knock. So, to demonstrate that, we're going to start it. Just try to get it to start. This fan, you have to start it on high as first, and then work your way down to the speed you actually want to get. Now, you can already hear the knock. This is the lowest speed on the variable speed control, by the way. It is solid state. So, the fan is very sensitive to voltage drop. So when the voltage, the voltage fluctuates throughout the day, if it drops too low, the fan won't work. Okay? The fan will just stall out. That's not good. So, we're going to turn the speed up a little bit. Maybe an eighth of a turn. Yeah, the friction drive is loud as hell. Especially when the drive wheel has a deformity. Slowly starting to speed up a little more. It's difficult to control the speed on this thing. It's very inconsistent. Sometimes it wants to go slow, sometimes it wants to go fast. Anyway. Hear that noise, isn't it lovely? Let's go full blast. Now the friction drive was made between about 1978 and 1982. There are two versions of this fan. Right? The version you see here, the Sears version, has a flat sideband, normal sideband. There were deluxe versions of this fan available, which had a brass sideband and brass blade irons. The Emerson version uses a motor housing that's more rounded. It doesn't have a defined sideband. But they're all made by Emerson, so no real difference. Surprisingly, it actually does move some air. Not a whole lot of air, but it's moving air. That sound is so nice. The friction drive, it was Emerson's attempt at an economy grade fan in the late 70s. It was their attempt at making a cheaper fan. Unfortunately, the design sucked. Okay. These things are unreliable. After a while, they'll just die because, well, they'll either stall out and the motor will burn out, or something else will go wrong because there's too much. It's a complicated design. So. And it's also horribly inefficient because the motor draws about, I want to say, 2 amps. Maybe 2.5, 2.8 even. This is not an efficient fan by any means. The motor is shaded pull. Whereas Newtone used a PSC, permanent split capacitor motor, which gave them an edge in both efficiency and power. So. Emerson or Sears marketed these things for outdoor use as well. Like they weren't, you know, because it's all plastic design. But these things were horribly unreliable, extremely noisy, not the best performer, difficult to use because of the kludgy speed control. And, well, yeah, they only lasted about 5 years. So, like I said, Emerson's a worst fan. And they've been known for making really good designs, so it's kind of like, why the hell would you do this, you know? So. Anyway, you can hear that noise going back up to high. And let it coast down. Another thing with friction drives is the coast down time is extremely short due to the design. Well, there you go, a god-awful Emerson friction drive.